Alright, champions, I've done it again. Taking it right down to the bare bones. We've got a couple of containers up there, stuff we'll keep, stuff we won't keep. And I'm removing the rust from this area. So this is an area that I've processed with some Scotch-Brite. I don't use steel wool, never use steel wool. The tiny steel fibres get everywhere. It's bad enough having metallic dust. But this will be vacuumed up immediately. So I'm going to work my way across, make the whole lot look like this. Around here, a fire's taken place. It's set fire to the paint on the chassis. And a lot of, well, you know, what would Brad's Guitar Garage be without a bit of carnage, eh? So, so the smoke residue, you name it. So we're going to take all that back till it looks like this. And then I'm either going to use some black one-step spray paint, prime and top coat, matte finish black stuff. I'll take out that board before I do that, mask up the area, or just some Penetrol, and we'll just treat that with a clear finish, and then we'll start installing our new sockets. We're going to go 4 new Beltons there, a new Belton there. That one used to be a PCB mounted socket. We're going to, well, they all used to be, but that one had the shield on it, which was riveted to the chassis. So I've drilled those rivets out. We're going to mount a one-piece combo one in there with the bayonet fitting on the socket itself. Going to mount, I might knock out this standoff since we don't need it anymore. That's riveted from the other side. Generally you can rock them back and forth and pull it out, clean up the hole, and mount a tag strip there for the long tail pair phase inverter. And like I said before on the previous video, we could put a tag strip mounted this way off this one as well. We could even mount tag strips on one going this way and one going this way. The world's our oyster, champions. I might do that, and then I don't have to worry about knocking this out. And that'll give us the relevant connections to go off to the output stage, which will all be hardwired. I've got to admit, doing this stuff's a bit fun. There's going to be comments, oh, it's probably not worth it on this amp, but I don't know. The customer has that say. I give them a price and they say yes or no. So I leave the ball in their court and make them aware of the market price, and they can either say yes or no. At the end of the day, if they go ahead, they're getting an amplifier made as good as it can be. It will live to fight many more years. So here's a look at where the fire took place. Not sure what happened here. I think it was, like I said in the previous video, a HT to heater short, because it's taken out this whole area where the trim pot for the heater balance used to be, and the previous person hasn't cleaned up smoke residue very well. But at this point I would have just said, yeah, it's time to call time on this board. But it did live to fight a few more years at least. I don't know how many exactly, but this was done a while ago. You can see there where the previous grid stopper's all vaporized. So this had a very catastrophic fault, which probably is the reason the output transformer's been replaced. And not sure how long ago, but you can see the original construction was pretty good. I don't like these one-sided circuit boards with no silk screen, but that was the fashion at the time, just like onions on the belt. Keep the vampires away or whatever. But yeah, you can see all the chaos now that we've removed everything. And all the damage. The damage is not restricted to just one side of the board, because even that header's fully melted. This would have been... There was a firefight! I'm all about the movie references, eh? Tell me what movie that's from in the comments. So we've taken all the boards out to inspect them. This has got all sorts of dry solder joints on it. Some previous repairs to the heater circuit as well. But dry solder joint galore, man. Like, this would have had so many issues even when it was functioning. Taking out the power supply board because we're going to do a recap while we've got everything out. Rude not to. And on the center valves, the Svetlanas, you can see the distorted reflection off the LED strip there. This one's been sucked in a little bit too. That was probably the pair of the other one that had catastrophically failed. So they're all cooked. And I don't know if you can see there, probably can. There's just a grey-brown haze. So those sides of the plates are where most of the energy is dissipated from, and it's actually gotten, that's where it starts to red spot when you get the, what they call the red plating. Geez, look at the reflection. I'm glad I'm wearing pants today. So parts of the, some particles of that plating on the anode would have been vaporized off, and they've condensed on the glass. It almost looks like a second getter there, but not quite as dark. That's actually anode material vaporizing and condensing on the glass because it's gotten that hot, and you can see the distortion to the glass there as well. So not very happy for that to happen. We've had Big problem. Also taking out the rear FX loop PCB just for inspection. There's no point taking out one board and not checking them all, so that way we can be confident when we've got this thing back together that she's going to be reliable. We've put her all back together, and I've got it under test. It's on the test bed now. We've got about 40% plate dissipation. I'm just watching that as the new valves burn in. Sitting around 473 on the plates. And pulling around 130 watts from the wall. This thing's just sort of indicative. I don't trust it as far as I could throw it. But it does show if there's any shorts or any weirdness, fluctuations, that kind of thing. So it is useful. So I'll leave the new EL-34s, they're JJs, in there just idling for an hour or two and just make sure there's no massive fluctuations or weirdness. Generally the dissipation will rise slightly in the first couple of hours of a valve's life, I've found, like by a watt or two. So we'll just let that happen, let it stabilise, and then come back and set the bias again. We're sitting around 40% at the moment, so we've got a bit of a margin there. And then I'll remove all this test equipment and show you what was done. Oh, right, champion. So it's all well and good, but what do we actually do? So, electrolytic recap. See all the new Nichicons there standing up for themselves. A lot of stuff that was previously connected via those sketchy ass connectors, that's all hardwired now. The biggest sort of labour area was replacing all the sockets there for the 4 output valves EL-34s, which we've locked into EL-34. I've taken out the bias select switch there to switch between the two bias levels, one for 6550, one for EL-34, and I've put a rubber grommet in its place. We cleaned up the chassis. I used some rust treatment on that, and some I forget the brand name, but it's a 2-part process, and then matte black over that. New phase inverter with a new belt and socket there, shielded socket, and 2 tag strips provided all the terminations we needed. We actually had 1 spare there. I may or may not put a preset depth control in this thing as well, just to give it a bit more balls in the bottom end, because the tone stack's a little bit silly on both channels, so it's a little bit boxy mid sounding. However, I don't want to do any voicing changes until the owner hears it as it was designed. We can do stuff in the future if he wants to go further down that road. Cleaned up a lot of wiring. Did a lot of heat shrinking where there was melted insulation, but the wiring itself was still okay. Hey, Penny Boy, focus day. Nice. All the heater wiring goes directly to those valve sockets first. You can see the green twisted pair down there, and then it taps off onto the preamp board from that point. The quick connects there have been removed because they were burnt and there was lots of damage to the underside of that board, as I think I showed previously. Now that's just hardwired to those traces. You can see a lot of these connectors had stuff for either the bias switch or just redundant stuff that with what we've done. We didn't require connectors going places. We could just hardwire everything directly where it needed to go. So there was a lot of jumping around between boards for a lot of connections that was not required with this new setup. So that's all a win, I think. We'll see. Things like the screen grid resistors are now mounted directly on each socket, so they've got better heat dissipation, and it's all worked out into a neat little package. Got some flyback diodes there, the other one over here for the other winding. Heater balance resistors mounted directly to one of the octal sockets there. You can see the 100 ohm half watt fusibles there. New droppers there because their leads were too short to lift them off the board, and for those first two I like to at least lift those off. And the remainder droppers are pretty happy. It's pretty unlikely that you get a dramatic short in the front end there, and even if you do, it's current limited by these bad boys. So these are the two that cop it if anything goes short circuit. That's the first 2 droppers. You've got the choke there, which is a purple wire. Your B plus feeds over here, and then that goes off to the purple wire, goes to the choke, and then the choke returns to the preamp board at that point. You know what, the biggest pain in the ass about this whole job, and the biggest time consuming thing and made me think why the hell did I take this on, was the fact that there's no silk screen on the board, and the fact that both the circuit diagrams and the flowchart and the connector diagram are both dramatically incorrect, even though they're for this model and this revision. So you almost had to trace this out like it was a point-to-point amp, because there's no designators for anything. Couldn't trust anything. Couldn't even trust like which valve was which. The codes for, you know, V123 were inaccurate. Everything was just throwing me through a loop on this one, so I had to like measure everything out, trace it out, figure out the signal chain and the structure of the amp in order to be able to complete it. Doing things like you couldn't trust anything, so like were the connectors as it was brought in, were they connected the right way around? So you had to check, you know, follow the traces and find the component it's connected to. And geez, if I thought Mesa Boogie layouts were bad, one of these leads connects to a trace which goes like all the way around here, way back around here, goes all over here, finds its way back up, and then connects to something like there. I was blown away. I would have traced it out for you when I had the board flip, but I was running out of time. Well, I've run out of time about 2 days ago, but that's beside the point. But yeah, back in the day of the single-sided boards and the auto layouts, yeah, you ended up with these massive traces, like, you know, goes from here to there via Albuquerque. So all the preamp valve sockets were good. We left them in. All the preamp valves are okay. I think V6, is it? 1, 2, 3, 4, 5, 6. Yeah, V6 is a bit microphonic, so I might change that bugger out. We'll see how we go. Maybe swap them around, put it into a less sensitive position. Now, someone mentioned in the comments that those impedance selector switches like to fail, and yes, I have seen it once or twice before, but this one's still in good condition. It's got low contact resistance, and I couldn't make it be intermittent, so without replacing it of one of the same type, which is about a $25–30 switch, I think. We'll keep an eye on that one. I'll tell them that if they have any issues with, you know, reproduction of the signal, maybe discontinue use until we look at that, but I couldn't get it to play up at all on it. There was no report of that. And even if it does, we've got the flyback diodes there, so we won't have a catastrophic fault if it does lose connection to the speaker, so added level of safety there. So it's just a close look at the output sockets and how I've wired them. I decided to go with the ground bus there for the cathodes. Made the most sense given the busyness of the area. And there's a close-up of the phase inverter. We've got some Mallory caps there, 150 series. 630 volt. The resistors are a combination of Vishay and Yageo 1-watt metal film, which are my preferred for modern style amps. And you've got one Panasonic 400 volter there for the feedback. Now I've reused the replacement knobs there. I doubt that Ampeg make these ones, even if the owner wanted them. I did use the set screw one on the frequency switch, which changes the treble cap value. Switches between various values, because it requires a fair bit of force to turn that switch, so that way you've actually got a set screw switch in there on an aluminium shaft. And as for the rest of the pots, I just reused the Ampeg knobs after giving them a good wash. You got to wash your knob every now and then, you know, rude not to. Alright, just look at the top side. Cleaned all those sockets up okay, they were good. The output transformer, I've stood upright. Used 2 of the existing threaded insert holes, as you can see down there. We've passed the secondary back in through the single hole, as I believe it was on the stock format, and drilled 2 extra holes to suit the different spacing, and we've put some nylock nuts and lock washers on the inside, as well as a oversized washer to help distribute the load. Choke and the The choke and the power transformer worked out okay. No excessive load or anything. When there was no load on the transformer, there was negligible power draw, so that's good. That's what we want to see. And we've got 4 new JJs in there, EL34s, and they all balance up pretty nice and match set. Cleaned off all that shmoo down in that area, and the writing actually survived underneath. The silk screen's pretty good. And where the MIDI mod board was, I just used some blanking grommets there to cover up the holes, because that's got HT on the circuit board there. You can fit your pinky in and light yourself up. So quite another time consuming repair. We're gonna have to start maybe being a bit more realistic about the hours around here. I think I take these ones on because they're a challenge, you know, but sometimes when you've got no silk screen and how do you know the schematics are wrong, you know? Like, I think I've got to study the available documentation a bit more before I rebuild entire sections of modern amps. And I had to get a little blingy lights on the front panel happening. The middle one's duller than the others, but I replaced it with a modern one, and it was just as dull. So I think the old ones used to have a bit more jam, but all the ones I had in stock are that type. I guess maybe they changed the type over the years, the preferred sort of bulb, so it doesn't blind you on stage. But this connector's a bit fucky as well. This is like every one of these connectors has got issues, particularly if it's taken a bit of current. But given that a couple of cycles and a clean with the blue-sided eraser to clean the contact seems to have helped, so that's good. Kind of hard to see from the front, but it gives a subtle glow to the back of the logo there, which looks nice. And the board's there, so why not use it? Alright, champions, this is the bucket of shame. This is all the stuff that came out of the amp and it was either removed permanently or replaced with a better option. It kind of feels good to look at a pile like this after you've spent so many hours on a job. And you know the hours have actually gone into some actual work. Actually. Did I say actually? Actually. Oh, champions. Turns out there was a reason this transformer was on its side. I looked at it in the cabinet when I had the reverb and the tank removed for cleaning. And I looked at the height relative to the power transformer, about the same height. I thought, no problem here, we'll fit that in. Turns out this is biting into the reverb tank by about 3mm. So I talked to the customer, and he barely uses the reverb anyway, but I've presented the option to go for a short reverb tank which will fit over the preamp side. It will get the output further away from the power transformer, so result in lower noise as well. And he rarely uses it, but at least the option will be there in that case. So I never said I was smart, far from it. I'm an idiot. I just can sometimes fix things. I'm a janitor with a soldering iron. If anyone thinks, oh, you think you're so smart, nope, I never said I was, and I continually prove the opposite. So anyway, carrying on. Alright, crisis averted. Got some nice pan head screws in there on the suspension mounts. No real need for the bag in this one, I don't think, so I've left that out. The customer wanted to use the reverb tank and bag in another amp, so I'm going to give, well, I'll give all the parts back to the customer, but I'll set the bag aside to go with the old tank. So it's not your traditional sounding amp, doesn't sound like a Fender or Marshall. It's very middly and boxy, very mid-forward. The EQ doesn't work as you'd expect if you've used most of the classic amps. Like the Fenders and Marshalls, the Voxes, partially because of the values in the tone stack being a bit weird and some of the strange coupling cap and bypass cap choices. But it is what it is. I'm going to keep the playing to a minimum because some snarky fuckwit told me that I can't play guitar to save my life, and I kind of agree, to be honest. But he was a guitar teacher, reportedly, and you'd expect them to be a bit more encouraging. But you know, that's what you get putting stuff on the internet. You get fuckwits. So anyway, I'll practice guitar, but in the meantime I'll play enough to show you whether or not this thing's okay. And we'll move on to the next one. So thanks for watching, champions.